Welcome to another deep dive. This time, we're tackling iodine. Sure, it's in salt, but this element has a story that goes way beyond your dinner table. We've got Wikipedia, the Royal Society of Chemistry's Element series, a whole bunch of stuff ready to get our iodine on.
Absolutely. I think people will be surprised how much there is to this element. It's essential and everywhere.
Speaking of essential, let's start with our bodies. Iodine equals thyroid health, right?
It's a vital connection. That thyroid gland of yours uses iodine to make hormones, T3 and P4 mainly, and they have a huge impact. Almost every cell in your body is affected by them.
Wow, every cell. So we're
Yeah.
talking growth, metabolism, brain power, the whole shebang.
You got it. They regulate all of that. And if you're not getting enough iodine, well, that's where the trouble starts.
Yeah, I've always heard iodine deficiency is a big deal. What actually happens? Like, what are the symptoms?
The classic sign is goiter. That's when your thyroid gland swells up. It's basically working overtime trying to grab any iodine it can.
So iodized salt really is the hero here, preventing all that.
It's made a massive difference. But how did we even figure out that our bodies need iodine in the first place? That had to be an interesting discovery.
It sounds like something that could have happened by accident almost.
Well, you're not wrong. Back in 1895, a doctor named Eugen Baumann, he was working with thyroid tissue, and he accidentally spills some nitric acid on it. You know what happens.
Let me guess. Purple fumes.
Bingo! It was a dead giveaway that iodine was present.
Okay, so purple fumes are a theme with iodine, because wasn't that also how it was initially discovered?
Oh, absolutely. Let's go back even further. 1811, French chemist Bernard Courtois. He's messing around with seaweed ash, trying to get stuff for gunpowder.
Seaweed ash for gunpowder. That's a combo I wouldn't have thought of.
Right, and he adds a bit too much sulfuric acid to the mix, and boom, those purple vapors appear.
So seaweed must be packed with iodine, huh? I'm picturing this chemist, lab coat, and piles of seaweed everywhere.
You're not far off. Seaweed's a great source of iodine. But those purple fumes are a clue to something fundamental about iodine itself. It's a halogen, right?
Right, but to be honest, I always forget what that actually means. Lay it on me. Halogens 101.
Think of halogens like a family on the periodic table. They all love to bond with other elements. Fluorine, chlorine, bromine, they're all in the club.
So they're kind of like the social butterflies of the element world.
Exactly. And like any family, each member has their own quirks, their own personality. So what about iodine? How does it stack up against the other halogens?
Well, it's the heaviest of the bunch, at least the stable ones. But here's the thing, it's actually the least reactive.
So it's the chill one of the family.
Pretty much. Still likes to bond, but not as aggressively as, say, fluorine or chlorine.
Okay, that makes sense. And those purple fumes we keep talking about, that's connected to iodine's ability to, what was it, sublimate?
You got it. It means it can go straight from solid to gas, skips the liquid phase entirely. It's like those crystals vanish into thin air.
Speaking of air, I remember reading that the ocean releases a ton of iodine each year. Is that why the coast has that, that particular smell? That's part of it, yeah. It's elemental iodine escaping, but also a compound called methyl iodide or iodomethane coming from the ocean gives it that distinct aroma.
Iodobethane. Do fish and seaweed actually make that stuff?
They do. Marine organisms produce iodomethane as part of the natural iodine cycle.
So iodine's going from ocean to air, from seaweed to our bodies. It's pretty wild how it all ties together.
Isn't it? And we've only scratched the surface.
Oh, I can tell there's a lot more to this story. I'm ready for more. What else have you got for me?
Welcome back to Iodine Land. We know it's crucial for us, got a wild discovery story, but that's just the start.
Yeah, I'm ready for some more surprises. Where do we go from here?
Well, let's jump to a place you might not expect. Medicine. But not just the thyroid stuff we talked about.
Ooh, okay, now I'm really intrigued. What else is iodine doing in the medical world?
Imagine a doctor needs to see your blood vessels really clearly, or get a detailed picture of your organs.
Like an x-ray.
More like a CT scan or an angiogram. That's where iodine comes in.
I actually had a CT scan once, and I had to drink this chalky liquid before. Is that what you're talking about?
Could be. They use iodine-based contrast agents. It can be a drink, an injection, depends. The point is, iodine absorbs x-rays really well.
So it makes those blood vessels or organs light up on the scan.
Exactly. Gives doctors a much clearer view.
So it's thanks to iodine that doctors can see inside us like that. That's pretty amazing.
It is. And speaking of seeing things, did you know iodine was also key in early photography? daguerreotypes, those old-timey
Oh,
photos.
yeah, the ones with incredible detail. I've seen those in museums. There's iodine in those.
You bet. They used it to create a light-sensitive surface on silver plates, helped capture those super detailed images.
Wow, so iodine's been shaping our world for centuries. It's like a hidden influencer.
It really is. And let's not forget something more, everyday antiseptics.
Yes. That classic sting of iodine solution on a cut. I can practically feel it now.
Exactly. You're experiencing iodine's antimicrobial power firsthand. It's killing bacteria, disinfecting the wound.
But didn't we say earlier that true iodine allergies are pretty rare?
Right. Got to distinguish between a true allergy and just reacting to the other stuff in those solutions. That sting, it's often just the iodine reacting with your skin, not an allergy.
So no pain, no gain. Or, well, sting in this case.
Pretty much. But there are some newer iodine antiseptics that are a bit gentler if you're not into the sting so much.
Oh, really? Like what?
Well, there's this thing called Iodozyme. It's used for chronic leg ulcers. It's a special dressing that releases iodine right onto the wound.
So it's more targeted. Less of that overall sting.
You got it. Scientists are always finding clever ways to use iodine's properties.
Okay, so iodine fighting infections, helping doctors see inside us. What else is it up to?
Get this, you probably interact with iodine every single day without even knowing it. Ever heard of LCD screens?
Yeah. Like my phone, my TV, pretty much everything has an LCD screen these days.
And guess what? Iodine is essential in making them. They use these things called polarizing films, and iodine is a key ingredient.
Wait, so there's iodine in my phone? How does that even work?
Those polarizing films help control the light, which is how you get those crisp images on your screen. Iodine's making it happen.
I would never have guessed that. It's like iodine is hiding in plain sight.
Right. And that's not all. Let's go industrial for a sec. You know, vinegar is basically dilute acetic acid.
Yeah, I use vinegar all the time, cooking, cleaning. What's the iodine connection?
Iodine acts as a catalyst in how they make acetic acid on a large scale.
A catalyst. Refresh my memory on that one.
It means it speeds up the chemical reaction without being used up itself. Like a matchmaker for chemicals helps create something new.
So iodine helps make the vinegar I put on my salad. I'm seriously starting to see it everywhere now.
It just goes to show how versatile this element is. But we do need to talk about one more aspect of iodine, and it's a bit more serious. Radioactive iodine.
Ooh, okay. Radioactive iodine, that sounds kind of scary. Radioactive iodine. Yeah, that does sound a little bit unnerving. What's the deal with that?
It's something we definitely got to treat with respect. Specifically, we're talking about iodine-131. It's a byproduct of nuclear reactors. It's kind of a two-sided coin, can be dangerous, but it's also got medical uses.
I remember hearing about iodine-131 with like Chernobyl and stuff.
Yeah.
Not exactly a good image.
Yeah, you're right. If it gets released into the environment, it can contaminate water and food. That's a serious health risk.
Yeah.
And it tends to build up in the thyroid gland.
Which can lead to thyroid cancer, right?
Unfortunately, yes. But here's the thing. That same tendency to target the thyroid is actually what makes iodine-131 useful for treatment, too.
Hold on. So the thing that can cause cancer can also fight it. How does that work?
It's all about controlled doses. Doctors can use it to target and destroy those cancerous thyroid cells, but without harming the healthy tissue as much.
That's incredible. So it's all about using it carefully, knowing how it works.
Exactly. It's like anything in science, understanding the power of these elements is key.
This deep dive has been wild. I mean, we started with iodine in our bodies, and now we're talking nuclear reactors and cancer treatments.
It's been quite a journey. What's been the biggest takeaway for you?
Honestly, just how widespread iodine is and how many different ways it affects us. I never would have thought the same iodine I put on my food is in medical imaging, photography, even my phone.
It really shows you how something so basic can have such a huge impact. We take it for granted, but it's everywhere.
Yeah, it makes you think, what other everyday things have these hidden stories?
That's the fun part. There's always something new to discover, some connection you didn't see before.
Well, I'm definitely looking at my salt shaker a little differently now.
And
And probably my phone screen, too.
it's a whole new perspective, right? So next time you come across iodine, whether it's in the news or just in your kitchen, think about its story. It's pretty amazing.
It's a story of accidents, science, and just the sheer power of this one element. And that wraps up our deep dive into the world of iodine. Thanks for joining us.
Always a pleasure exploring these hidden corners of science. Until next time, keep those questions coming and keep on learning